Hello everyone, and welcome back to this next video in the Houdini Academy Foundation module. In this video, we are going to continue with our staircase element over here. And where in the last video we created the outer housing, in this video we are actually going to take care of the stairs inside. So we can go and finish up this part of the module. So let's have a look at the code for the staircase, because it's actually comprised out of three different components. Over here we have our staircase, and the outer housing is currently displayed as a wireframe. So down below, if I look closely at the actual staircase element, it's basically a combination of a landing, a series of steps, one for both sides, and then a back turn, which is kind of like a half spiral staircase. And each of these elements are then combined together. So here we have the landing right there. This part here is one of the two staircase elements that are placed in position. And then here we have the spiral element. And based on the size of each element, they will be positioned properly. But if you look closely, let's say over here at the door, you'll notice that this is actually slightly taller than our door. It doesn't quite reach the landing where it should be. So to correct that and to make sure that it's placed properly, we're going to take the height of this element and scale it down to fit in between the layers of our building. So as we copy them up, we actually also scale these elements down a bit to compensate, so they always fit exactly in place. Now you'll notice that our back turn also has a cutout here, and that's to make sure that if the building gets too small, the player won't bump his head on this element. Because while I could have created just another landing for the back instead of this spiral element, I wanted to make something slightly more advanced and to show you how to make that. But to make sure the player can't bump his head, because this is too thick in some cases, right? Because it does have some height for the steps, I needed to cut out an element over here, so the player does have enough headspace to traverse down the stairs. We'll go over that when we get to it. And then finally, we'll combine this back together with our housing over here. So we're going to copy our housing into place, and then we'll also copy our staircases, merge them together, and then we'll have our final result. So let's get started on that. Let's move over to our main project. And the first thing that I would like to do is add a new section over here inside of our building staircase steps. Now, as I showed you, we do have our landing shape. We also have our staircase left shape, and we have our back turn. And we're going to create different elements based on each of these. Let's first start with our landing. So in this case, I'm going to create a grid. And let's call this node the landing shape. And I want to make sure that this grid is the exact size of our current landing. Now, I could potentially grab this data here and try to clean it up. But in this case, I'm just going to create a spare link and provide some bounding box and centroid expressions to get the exact shape and position of our landing there. So let's click on here, on our landing shape, add a spare input, and let's plug in our landing. Let's set the amount of rows and columns to 2. And then for our size, let's type bounding box -1 d_x size. Let's copy that, and let's paste it over here in the second channel as z size. Then for our center, let's type centroid -1 d_x. And then also here for the z channel, let's set it up as well. So that will deal with that, and this will make sure we have the landing in the right place. Then next, we need to give this thing some depth. Now for this one, I'm going to copy over here from my left under our create floors section, the extrude and texture floors, because this one already has most of its textures set up properly. So we just need to make a couple of adjustments to that. Copy this node and let's plug it in over here. Alright, so we need to make some adjustments here because, like I showed you before, I want my landing to be the actual point where the player is going to stand, this shape here. And I want this to be extruded down. Now, as you might recall, we created this system so it could only extrude up, right? If I try to take the height of this floor here, let's remove this expression, and I try to set it to say minus 0.3, it will return 0. And that's because I locked this asset at 0. I want to undo that and actually allow it to go below 0. But if we do that, we will actually invert our mesh. Let's first set this up and then I'll show you how we can fix that. Let's allow editing of contents. Let's go to our type properties. And then in here, under extrude depth, I'm going to turn off lock at 0. Let's apply that. Close this. And now you can see, like I mentioned, it actually inverted our normals, because right now it's extruding down, which means that all of our shapes are inverted. And as a result, we get an inverted mesh, right? Under normal circumstances, I wouldn't extrude down to create an inverted mesh. But to fix this, we can simply reverse the mesh ahead of time. So we get a mesh that's actually, outside out instead of inside out. Let's grab a reverse node, plug that in between, and there we go. So our source mesh was upside down. If we then extrude down, we get a mesh that's correct. So cool, that works. So in this case, I've saved the node when I changed the parameter, but just in case, I'm going to say save node type, and then I'm going to match our current definition. So that should be working just fine. Let's rename this one to landing. Okay, so next let's set up the height of this extrusion. And for that, I'm going to set it to 3 times the actual step height of the player, or rather the target step height of our entire staircase. And we need to actually create a separate parameter for that somewhere that we can pull from. Now, I'm not going to promote this to the top interface of the tool, though we definitely could. But in this case, I'm going to leave it as a fixed value inside of our tool, and it's up to you if you want to promote that up to the top. So here I'm going to create a null, and I'm going to call this one the step height null. As for its color, I'm going to make this one dark blue, because this is going to be a data node that has an important variable that we can pull from. And to make this even clearer, I'm going to wrap this inside of a little net box and call this one step height as well. And I'm going to make this blue as well. So the reason I'm doing this is so it stands out, and I know this is an important node I don't want to delete. Then on this node, let's open up its edit parameter interface. And I'm going to hide these elements here, make them invisible. And then I'm going to plug in a float. And this is going to be a float called step height. Now, as for its range, I'm going to set this from 0 to 1, but under its channels value, let's set it up as 0.2 by default. So with that, let's accept. And now we have a value we can pull from for the step height of our entire staircase. I'm going to copy this value, and then under our extrude and texture landings node, let's plug it in over here behind the minus, paste relative reference. So that will give us an expression like that. And then I'm going to multiply that by 3. So our landing is going to be 3 step heights deep. Okay, so that deals with this element. Now, right now, it's still at the grid level. We'll copy it into place once we have all the other components, because our landing is going to be the highest element in our staircase. In fact, if we look at this and we look at the links between them, the landing is going to inherit the position of the highest staircase element, this one, and then we're going to sit it on top of that. So we actually have the lower staircase, then we have the back turn, then this step, and then the landing, in that order. So let's leave this element alone for now, and I'm going to work on the next part, which is going to be the steps. So let's look at that one. I'm going to copy my landing shape, plug it in over here to the right, and I'll rename this one to the straight steps per flight. And then I want to make sure I reference my stairs left as my spare input. So this will grab its shape and bounding box. Like so. Now if we look at the actual staircase itself, at the full shape, the landing, the steps and the back turn, it's going to sit in here as 1/2 of the staircase, right? So if we give this a certain amount of steps, it needs to have about 1/2 of those steps. Now the back turn does have a couple of steps, but not too many. So we can kind of discard that one in this case. What I am going to do though, is make sure that this one never has too many steps, but also never has too little. And we can control that over here under the columns section. Now the amount of elements that we have in each one of the sides of these stairs is going to determine how many steps we actually have. But because we have a fixed step height, and I want all my steps to have that same height between them, we need to actually control how many steps we have and then approximate that value as much as possible. Let me try to explain this, right? So let's say we take our staircase here and we take our height of our floors. Let's grab the parameter interface for this one. So if I take my floor height and I set it to a value of say 3, then we don't need as many steps in order to get up to the top, okay? And even our back turn will have less elements, less steps to walk up on. But as we increase the amount to say 4, we get more steps. And up to 5.99, we'll have this amount of steps, and that's the most we're ever going to get. After that, once we get up to 6, we actually start duplicating this step, this entire staircase element, up, so we have multiple flights between each level. And as a result, we don't need as many steps. And at that point, it's going to reduce the amount of steps again to its lowest value. So in order to set that up, we need to take into account the actual floor height. And then we need to do a little equation to make sure that we have enough steps, that our step height is close to 0.2. Okay. But then we also need to start cutting our step height by a certain value, basically divided by the amount of copies that we have per level. And for that, I'm going to write this expression, this part over here, which is basically going to take the floor height, multiply that by 2, then we're going to divide that by a sealed floor height divided by 5.99. This will create a value of 1, 2, 3, etc. every time our floors go above the duplication limit, which is 6 meters. And then finally we have this +1 value here, and this is just to make sure that we have an uneven number, and that has to do with how the rows and columns work, right? We need 2 rows to create 1 primitive. 3 rows would be 2 primitives. So in other words, +1 just means that we have the exact value we want. It's easier to show than to explain. So let's go over to the file and let's set this up. So over here for our straight steps per flight, let's copy the floor height from our parameter panel. copy that parameter, and we're going to plug it over here under columns. Now to make it slightly easier to work with, math-wise, I'm going to set this up to a floor height of 4 for now. Now, what we have right now is 4 columns, and that means that we have 3 primitives. But because this is only one side of our staircase, we actually have 6 steps in total. Now, let me grab my calculator. And if we have a floor height of 4, and we divide that by 6 steps, not really counting the back turn in this case, then we'll end up with a step height of 0.66, which is much too high for the player. I mean, I don't even want to try and climb a staircase with a step height that high in real life. So let's say we double this up. Let's take our floor height, multiply that by 2. So now that we have 7 steps, it's a bit more manageable. So now that we have more steps, let's try and figure out what our step height is now. Let's create a parameter on this node. So let's open up its edit parameter interface. I'm going to drag in a float, and I don't really care what it's named, but I'm just going to call this one step height diagnostics. Something like that. And then let's accept that. And then in order to write this diagnostics, I'm going to grab my floor height, copy that parameter, plug it in here. And then I'm going to divide that by my columns, plug that in there. Then because our columns are actually based on the edges, not the primitives, we need to subtract 1. Then I'm going to wrap this inside brackets to make sure this equates before we run it through the division. And then I'm going to multiply that by 2, because we have 2 sets of these stairs, so we need to double that up. Let's also wrap that inside brackets. And with that, if we equate this, then we can now see the step height, or at least the approximate step height of each of our steps here. If I raise this and raise the floor height, then you can see that we have a step height of in between about 0.25 and 0.3. I want to bring this down a little, so under my equation, I'm going to wrap this inside some brackets, and I'm going to add +1. This will add just one additional row in there, so we have a total of 8 steps in this case, and that will be 0.5. So that looks fine. Okay, but now we're getting to a bigger problem. Let's say we take our flight of stairs and we multiply it up to maybe 11. In this case, we have 22 steps on each side, and we don't really want that. So to make sure this is fixed, let's go back to our columns, and then in between our floor height brackets and +1, I'm going to divide this by a sealed value, so a round to ceiling expression with the floor height, and then divide that by 5.99. This is very close to 6, but just to make sure that when we reach a value that is divisible by 6, we don't get wrong rounding, I'm going to make it slightly lower. You'll see what this means. So as you can see, we now have 12 steps. But if I start bringing up my floor height slightly, once we go over 12, or we are exactly on 12, it actually snaps back down to 9 in this case. So just 9 steps. And that's perfectly fine by me. Now at this point, because we're over 6, our diagnostics won't work properly anymore. But if I were to go to say 5.9, then you can see that our maximum step height in this case is going to be 0.25, which is not 0.2, but it's close enough that I'm going to give it the benefit of the doubt. Plus, we're not actually taking into account this part here, and the fact that it's going to scale slightly, so we're probably going to be closer to 0.2 than 0.25 in the end anyway. Either way, if you have this expression here set up, then this part should work properly. Alright, now that we have the correct amount of steps, let's actually give them their correct height as well. So for that, let's first create a unique points node. And the unique points node is simply going to take this mesh and break it up, so we have individual primitives. Then let's create an attribute wrangle node, plug that in, and I'm going to call this one right step elevation. This is going to be a node that controls the variable for our step height. For that, I'm going to write to a primitive attribute. So while running over primitives, let's type 2 slashes so we can write a comment. I'm going to write here set elevation based on primitive number. And then below that, let's write f at elevation equals the primitive number plus 1. So we start at 0, but I want to actually raise up the first step by 1 step height, so I'll add 1. And then we're going to multiply that by a channel float value for the step height. So let's type step height here. So this code here is going to basically take every primitive, take its primitive number, and if I raise this value, if we look down here in the geometry spreadsheet, it's going to give it its own unique height value. However, this is not actually going to set the height. This is simply going to create an elevation attribute that we can then use to set the height. So I'm going to set this one to 0.2. Let's go up here to our step height. Copy this. And let's plug it in here. So that's what I meant with a master control. This node here is going to drive all of the step heights throughout our entire code. It's going to make it a bit easier to manage. So we'll have some links right there, lots of dependencies. Now that we have this elevation attribute, let's promote this up to our points. So right now it's a primitive attribute. Let's create an attribute promote. I'm going to call this one promote elev to points. Set it from primitive to points, and let's select the elevation attribute. So now it's over here under points. Then I'm going to create another wrangle, and I'm going to call this one set step elevation. So in here, let's write out as a point attribute v at p.y equals the float attribute elevation. And if I add a semicolon there, it's going to raise up every single step based on its point attribute elevation that it got from the primitive that it originally came from. So this will work, and this will create our steps. So that's pretty simple. So next, I want to give these some depth. And for that, we can simply copy our extrude and texture node over there. So let's copy this extrude and texture node, paste it in below. And because this one is extruding down, it is of course going to inverse my normals. So I also need to reverse this shape. Let's go up here and let's drop a reverse node in below our grid. So that should deal with that. Okay, so now that we have our steps, let's adjust them a bit so they look a bit better. Because right now they have some repeating textures going on. We have this triangulation pattern, and I also don't like the fact that our steps at the bottom have this stepped pattern here. So I want to adjust that. let's go to our extrude and texture node and let's disable the triangulate results option. So that's 1. Then, next, let's deal with the repeating pattern that we see on this shape. And we can do that by offsetting the UVs that this node has created. So the UVs for the sides are the ones that I actually want to affect. Let's look at those. Over here under our vertex attributes, we have our UVs right there. And if I look at this node, we have a series of groups over here that are being output by the node. So we have them for the sides, the floor, and the bottom. What I want to do is offset the UVs for the sides only. And the nice part is this is a primitive group, and vertex attributes in Houdini can be addressed using their primitive. So let's create an attribute wrangle over here. Plug it in. And since this is going to affect the material, I'm going to color this green. And I'm going to name this one offset side projection. Let's call up the UV view again, split in 2, and switch to UV viewport. Okay, so the UVs that we see here for the side of our steps is this set here. If I look at my groups, then you should be able to see it as a highlight. If I change this color, there, it's the yellow one. So over here in the attribute wrangle, let's switch it over to run on vertices. And then I'm going to say vector attribute UV dot X, that is the position in the X direction, or the U direction in this case, plus equals a random value based on the primitive number. And what this will do is it will add a value between 0 and 1 randomly based on the primitive that these vertices were on. So if I apply that, now it will offset the texture between 0 and 1 on the UV space. And if I apply that only to the sides, then it will only offset that part of the texture, not this section. So that's a neat little trick. And what this is going to do is it's going to make sure we don't have that repeating texture pattern over here. Right? So our steps will look nice and unique. Or at least as unique as they can be with the same texture. Alright, so next let's deal with the mesh itself. And let's remove these steps from the bottom, because I do want to make this a slanted section. Now to do that, we will have to create a separate shape so we can cut from this once again. Plus, I also want to unify these elements, because if we look inside, they're still just boxes that are somewhat intersecting with one another. So to fix that, let's create a Boolean union node. And as long as this is in a cardinal orientation, which it is, it should have now created a proper mesh inside. And this will also be useful when we try to bevel this thing later. Okay, so let's call this one Boolean union. And then let's deal with the bottom. So for that one, what I would like to do is add another section here on the left. So I'm going to grab this part of my network for the landings and pull it down to somewhere over here, so I have some space. Then over here, let's create a new copy of this node, the straight steps per flight. And I'm just going to call this one the straight bottom. And in this case, I'm going to reduce the amount of columns back to 2. So let's just delete that expression on this one. Set it to 2. And we can actually get rid of this spare parameter here. So I'm going to right click and say more delete spare parameter. And it's going to ask you, are you sure? I'm going to say yes. Delete. So that gives us a clean node to work with. And again, this is going to be a simple grid that's based on our stairs left. But in this case, I'm going to use the same trick I used here, but I'm going to use it on its points. So let's deal with the height of this one as well. Let's have a look at the steps. What I want to do is set this one up so the points on the left here, 0 and 2, are on the ground, but then 1 and 3 are going to match the height of the highest step. And for that we can basically simply create a link between these. So let's create a new attribute wrangle. Set it up here. And I'm going to say right bottom elevation. Then for this one, it's going to be a point attribute. Plug it in. And I'm going to write out a new elevation for points 1 and 3. So up here, let's specify those. Then as its expression, let's say v at p.y, so the point position in y, is going to be the amount of primitives that we have on this mesh times the step height. So for that we can grab a line from over here on the right, plug it into the second input of this wrangle, which will allow us to reference it using value 1. And then I'm going to say number of primitives as an expression of input 1 multiplied by float value step height. If I do that and I expose that, let's create that parameter and let's raise it. Then we can now control the height of these 2 points. If I set this one to be equivalent to the step height, copy that parameter, let's plug it in. Then now it will be exactly up to that point. So you can see how it follows the steps. Okay, so next, let's also give this thing some depth so we can start using it as a cutting shape. Let's grab our extrude and texture node over here, copy it, and let's plug it in. Now again, we are extruding down, so let's also add a reverse node up here. So we have a proper oriented shape. And then we can take this and we can start cutting our current shape. So this one with that. Now at the moment, these two aren't properly aligned, so I do need to make some adjustments to that. First, let's create a transform node here. And I'll call this one lower. Plug that up. And I'm going to lower this extrusion shape by the step height and then add a little bit extra back. And I'll show you why. Let's grab our step height. I'm actually going to pull this out as a parameter so I can grab from it easily. Let's say we copy that. And then let's copy the step height into our transform node over here into translate y. I'm then going to take that and let's subtract this value times 2. If I do that, then it will now place itself at the bottom of our shape, right at the bottom, right there. And this might be just a little too close to the bottom, so I'm going to raise it up by 0.01 as well. So let's take this, wrap it inside of brackets, and then I'm going to say plus 0.01. That's just to make sure that we don't have a weird cut right at this intersection there, just to keep the precision proper. Now let's have a look what this looks like when we actually run it through a Boolean node. Let's use a Boolean subtract. Let's take our Boolean union as the first value, and then this extrude and texture node here. Then now it should cut this out properly and apply our texture right there. Now, I'm not 100% sure this is completely secure, and this has to do with the fact that this is a diagonal shape. We are cutting at a non-cardinal angle, and as a result, this might break. So what I want to do is expand this shape just a bit so it encompasses the entire mesh over here by just a fraction of a value. So I'm going to create a poly extrude node. I'm going to place it over here before our lower. Then I'm going to take this value over here under inset, and I'm going to inset this inward just a bit to give it a bit more space. Now you'll notice that it's going to do this trick where it has some sides as well, some extra polygons, because ultimately this is an extrude node, right? But if we set our distance to 0 and we only use the inset, then it will basically just expand our shape outward. If we don't output the sides as well, then we only keep the front, and that means that regardless of the original shape, this inset is going to simply expand it along its own normal direction, which in this case is this direction, which is perfect for us. So I'm going to set this one to minus 0.01. That should be enough for the Boolean node not to get into any kind of trouble. And then if we push this down and Boolean it, then now it shouldn't cause any issues with our extrusion or with our cut. So with this setup, let's call this one the Boolean subtract bottom. And let's make sure we name these other nodes here as well. So this is going to be the straight steps bottom. And this is going to be the straight steps. Okay, so that will deal with our steps. And now we only have one more element to build before we can start adding these guys together. Now I'm going to split the video here because otherwise the video will be too long. So before we continue on to the next component, let's stop here and let's pick it back up in the next video. So thanks a lot for watching this one, and I'll see you in the next one. Have a good one.